Welcome to this video on free energy changes and temperature. So what we're going to look at now is how free energy changes with temperature. So we've got this reaction here, water gas going to water liquid, delta H, delta S. And we want to look at what happens to delta G when you change the temperature. So we've done it before in the previous slide. This is the relationship we're looking at. When temperature is equal to 0, so that's the first thing you're going to look at. To do these plots, you're going to look at when T equals 0, what is delta G. So you're going to look at this and you're going to see that at this point, if T is equal to 0, basically you can get rid of this term here completely, and delta G is just equal to delta H. And so we can mark on the graph here that at 0 Kelvin, we'd expect the free energy to be minus 44 kilojoules per mole. Now when you start to increase the temperature, you then need to think what's going to happen as you increase the temperature. So what happens to delta G as temperature increases? And the key thing to consider there is to consider the sign of the T delta S term. That's the key thing to do. So here we have minus, and then delta S in this particular case is going to be a negative number. So minus times a negative number gives you a positive number, and so that will mean that delta G will actually become more positive as temperature increases. So, and because we're doing it as a function of temperature, temperature occurs with power 1 here. It's going to be a straight line relationship. It's going to look something like that. Let's try again and see if we can get a better straight line. Something like that. And we actually worked out in the previous slide that the tipping point is at 370 Kelvin. So that's what it looks like there. Now what I'd like you to do now is to try and think about 3 other reactions, one with a positive enthalpy and positive entropy change and so forth, and try and see if you can sketch on similar axes to these how delta G is going to vary with temperature for each. And then I want you to think when will each one be feasible. So this one here, for example, if we have a negative entropy change and a positive negative enthalpy change, this is going to be feasible at low temperatures. What about the others? Have a look and see. Well, let's see how you got on. So here are the graphs that you should have for each one. So blue was the reaction that we did before. In the case of the red reaction, we've got a positive delta H value, and remember at 0 Kelvin that's the same as delta G, so we're going to be positive there. And then we've got a positive entropy change. This is going to be minus a positive number. In other words, it's gradually delta G is going to become less positive, and so we've got this situation here. Again, we've got a tipping point between not feasible at low temperature and feasible at high temperature. So if we have positive and positive, we're going to be feasible at high temperature. We've done the negative and negative case, which is going to come over here, and that was feasible at low temperatures only. This is this blue line here. Then you've got 2 other cases to consider. You've got this dark blue line over here. Just switch to that colour pen. The dark blue line over here is a positive enthalpy change and a negative entropy change. So we've got a positive enthalpy change, which means delta G is positive at the start, so it's not feasible at 0 Kelvin. And then because you've got a negative entropy change here minus a negative number, that's just making delta G more and more positive, and so it just continues to be less and less feasible. And so if you've got a positive enthalpy change and a negative entropy change, then it's never going to be feasible. And if we think about those reactions that we did right at the beginning, neither of the feasible reactions had the combination of a positive entropy change and a negative positive enthalpy change and a negative entropy change. Our final one is in purple here, a negative enthalpy change, and so delta G starts off negative at 0 Kelvin, and then if this is positive, you're just subtracting a bigger and bigger number, so you're becoming more and more negative, so in fact you are always going to be feasible.